Okay, so we continue with hashing for blockchains and cryptocurrencies. So I said that one of the biggest misconceptions is that people think that cryptocurrencies involve encryption, but actually they do not. I mean, you can put encryption. There's actually a Bitcoin proposal for that, but it would not be the same. Since everybody can read the data, there is no point on encrypting the block data. But we said that the other cryptographic algorithms are used in cryptocurrencies like cryptographic hash functions and digital signatures. And don't forget that hashing is not encryption. I have to insist on this because a lot of people in Turkey think that this is encryption, but it is not. Okay. So cryptographic hash functions are used to provide immutability in a blockchain, and digital signatures are used to prove ownership of digital assets in a blockchain. But we also talk about that other areas in cryptography found their way in blockchains. But our main topic is hash functions. But these hash functions can be used in many different places. And I want to give generic examples where a hash function is useful for. So let's talk about the following use cases. A forensic investigator would like to have a very small digital fingerprint of every storage device at a crime scene to detect if any modification to these drives happen in the future. Sorry for the typo. So it will be fantastic if you can go to crime scene and assume that there is an 8 terabyte file, hard disk there. You just take the hash of it, and you know in the future if something goes wrong, you can say that the contents of this hard drive is modified. So you can also do this for every file in the drive, and actually you should do it. Another thing to use hash functions is that maybe you want to find all duplicate files in your disk. So this is a very good exercise actually. Just write a simple software taking hash of all of the files in your computer with the path of those files stored also. Then sort them. So this way, when you sort them, if two files are the same, their hash values will be the same. So this way you can find the duplicate files. Because most of the software just check the file names or the size of the file, but these are not enough to detect the duplication. The true duplication can be found by checking the hash values. So another example from the cloud. Millions of users upload the same file to cloud, but cloud provider wants to store only a single copy. So how do you do it? You just check the hash of the files people are uploading. If they are the same, you simply store only one of them. And this is how cloud works actually. And another good thing is that if you're going to do this in the cloud, since somebody wants to put the same file on the cloud again, you just check the hash values before they upload the file. And this way you can say that, okay, don't upload the file because I already have it. This way you also save the bandwidth, right? So hash functions are really fantastic. Another use case, since we are talking about cybersecurity, we would like to talk about forensics. An intelligence agency wants to give a list of illegal files to forensic investigators without sharing the files themselves, right? This is actually what they do. So you have maybe a storage of illegal files, could be child porn or anything, but you don't want to give these files to somebody else, right? But you want to detect if somebody also has those files. The easiest way to do it, just take the hash of them and give them to forensics people, right? So in that scenario, forensic investigator obtains a disk and want to check if there is any illegal file on that disk. So in this case, you will use the list that is given to you by the intelligence agency, and you will just check them if they are the same. This way, without even looking inside the files, you can see if they are illegal or not. Okay, so there are many ways to use hash functions. You can even create your own Kickstarter company just using hash functions. There are many ways to use them. But for the blockchain, we have different uses. So in a blockchain, hash functions can be used for address derivation, securing the block header, securing block data, creating unique identifiers, and creating cryptographic puzzles. So with this introduction, let's now talk about what a hash function is, right? So the definition is as follows. A hash function h is a keyless algorithm that takes a variable length input x and returns an output y of fixed length n. So for this fixed length n is called message digest length, and the output is sometimes called message digest. So if you're using SHA-256, this means that the output is always have a length of 256 bits, okay? Regardless of the input size. The input can be 1 bit or 1 terabyte. It doesn't matter. The output is always have this fixed length, 256. But of course, this definition of hash function is a general definition, can be used in maybe in databases to save storage and so on. But for cryptographic hash functions, we want more properties. So we expect a cryptographic hash function to satisfy the following properties: preimage resistance, second preimage resistance, and collision resistance. So we will talk about these properties. But moreover, we actually also want a hash function to behave like a random function, which means that actually the output of the hash function should look like random. Okay. Actually, this is used in hashing puzzles. If it is not random, then the hashing puzzles will not have the uniform difficulty for every challenge, let's say. So let's start with these definitions. Let's talk about preimage resistance. Given an output y, it should be computationally infeasible to find any input x such that hx equals to y. Okay. So once you have the output, you also know the hash function. It would be computationally infeasible for you to find an input that would give this output. Okay. So a generic attack would require around 2 to the n operations because the output y has n bits. So if you randomly put 2 to the n inputs to this hash function, you expect one of them to hit this value y. Okay, so this is why a generic attack requires this. So this is why we choose the value n depending on the current computational power of our devices. Okay, in a password file, one does not store, here's an example why we need a preimage resistance. For instance, in a password file or a database, one does not store directly the username and the password, but it would be good if we store the username and hash of the password so that whenever the database of this file leaks, people will not capture your password, but the hash value of it. So this way, they will not be able to recover your password. So actually, a lot of people in the early days of the internet stored the password like this. So this is why a lot of web pages or commercial sites broke in the early 2000s, okay? So the simple idea was to use this hash value instead of the password. This is sufficient to verify a password because once you, for instance, want to log into Facebook, you provide your password to them, they compute the hash of it and check if it is the same as they stored in the database. An attacker that captures the password file has to find a preimage. So we know that finding a preimage is hard. So this is why you are secure. But of course, this is not how we store the passwords in real life, because it is still possible that your password might be short or easy to guess. So the attacker can try a lot of short passwords to see if it matches with one of the hashes in the database. So as a side note, not that important for this course, but in practice, we concatenate a random value called salt to the end of your password. And instead of calculating the hash of this value, we repeat this hash process thousands of times to slow down the brute force attack of the attacker. Okay. And actually, you might think that do we need it? Do we use this in blockchains? Actually, in wallet software, this is what you do. Okay. You chose a password to encrypt your private key, and this is what happens in the background. Okay, the hash of your password is calculated thousands of times, and then the result is used as an encryption key, and so on.